right, we're back. And with the title up there, now we'll transition. All right. Well, good day, all. This is my second attempt, this is my second episode of season 2. Let's say that. More specifically, what I'm trying to do is come in here every day, but not for very long, doing just the smallest amount of editing. Now, from yesterday, I promised that what I would do is go through a series of topics with 5-minute introductions, and then allow folks to help me sequence the topics that we're going to cover, particularly since I'm going to be expanding further into some RF related things. Now, today is going to be a little bit of activity. I'm looking at I have a fellow ham who is looking to get his general license that's local, and he is setting up a base station with a HF radio, and he wants to be able to do UHF, VHF, and he has a very nice Kenwood handheld that normally goes for about $800 plus. It's a D74, I think. I'll put something in there, and it's an interesting fella. Now they've subsequently made a new one. I won't go off on it too much, but anyway, we're trying to work something out where we can maybe do a trade, and it's a really cool handheld because it has a TNC, it does APRS, it's Kenwood, and it does D-Star, and D-Star is a digital mode we'll be talking about, developed by basically an open source, more specifically open standard protocol for doing digital voice and data over RF and the internet. But we'll get back to that. Anyway, so I'm doing two things. I apologize, I've got some notifications going on there. I'm going to be I'm making sure that this ICOM 7100 radio, which I do love. Wow, there's just so many notifications right now from all sorts of things, and I just really apologize because I guess I didn't realize that things would be blowing up at 7 a.m. So I've attempted to mute those notifications. We'll see. Anyway, we have the ICOM 7100. This is just the head unit, but it is nice because, and I don't know how well you can see, but so you've got a built-in speaker. You've got you can plug in a mic here, and you can, and then it uses a shielded Cat5 straight through cable to connect to the base station, which is still a mobile base station, so it's not that big. You'll see it here in a minute, but it's about the same size as this box, maybe a little bit smaller, and we'll talk about this in just a second. Anyway, and then the other two slots here, I wish one of them was for data. That would be nice, because there is a serial data line, but I'm not going to go into that right now. But one's for a key, one's for a Morse code key, and the other one is for your headphones or an external speaker. And then on the bottom here, it's really nice because you can put a mount in here. It's also got a threaded screw spot that fits into whatever the size is for like a tripod mount, so that you can put it up there. And there's a couple different accessories for it. Anyway, this is a fantastic radio, and I'm glad that hopefully it'll get to go to a good home. But he's got he wants to see it stuff. So we're going to go out to the park. I have a portable setup that I just used with my 7000, IC 7000. It's an ID or IC? This one's IC. 7000 that I took to the beach with me. I'm going to use it, the 7100. Well, one of the other things that I guess I'm trying to get rid of, not sure if he's going to take it or not, but is one of these manual antenna tuners. And every HF station, in my opinion, needs at least one of these MFJ manual antenna tuners. I have, this is the mobile version. It just means it's a little bit smaller, and I think that may not be able to resonate quite the same antennas. More specifically, it doesn't have a random wire. And it doesn't have a dummy load, which the Big Brother does, but we're not talking about that one. Anyway, this guy has a couple little things that I want to make sure are tightened up on the inside, particularly this knob. I want to make sure that that's doing what it needs to do and not wiggling around too much. Anyway, these are nice, simple machines, and what you use it for is to match the impedance of your feed line, your antenna, and your radio so that you don't have reflected power. There are automatic antenna tuners that you can use, but I think every ham radio operator that is, or amateur radio operator that's getting into HF should at least have one of these, not only as a reference but as a learning tool, because what you're doing is selecting these different like inductors and then changing a capacitor, a variable capacitor. And let's just go ahead and take it over to the bench and I'll show it to you. All right. Well, to be honest, you're just gonna have to excuse the bench because I don't have it all set up right. Currently, I'm going to turn off this other radio, and I apologize for the dings. I'm trying to turn them off as much as I can, but I guess folks are just really after me. This is the manual tuner on top of the bottom part of the radio. Let's see if we can get just a little bit more light. Anyway. So they're about the same size. I guess the radio's about a little bit bigger. Yep. All right. So I'll try out the radio here later on. Probably not today in this video. I just wanted to be able to take this apart. So I'm going to take it apart. Oops. Oh my. Yeah, hot mess here. I'm going to take it apart and let you see what it looks like inside. Now, I'll be honest, I don't know if I've actually taken this one apart before. But one of the things I love about these MFJ products is that basically what, and I think there's a mastermind behind it, but the founder, yeah, Celius. So what they did is, what he does is, what his history is in the MFJ product line, is that he would take like published specs, things like that from amateur radio magazines, and then make it into a product, which this is very inspiring to me. And been around for a long time. This is a good design, because the other one that I have, you have to take off the whole thing. Anyway, so that was 2 screws, and we're able to get in here. And yeah, so what you have here, let's see if I can get in nice and close for you. I'm going to get in nice and close and hopefully have, just tell me. Okay, let's get in nice and close. What do we got? Yeah, we'll tighten. Sorry guys. There we go. apologize. I'm still figuring this whole thing out. Okay, so what you see there is literally what we are doing. Okay, wow. So see this dial for inductance, right? There's a couple things going on there. So what it's doing, I'm not going to make this a detailed, super detailed, but what we've got, you can't quite see it in there, but each one of those, when you turn that knob, it selects one of these wires, and those wires terminate, they terminate into this coil, basically. Okay, so and then what we have is a toroid here, a big inductor. So we're going we're going through, and this is a length of wire. So what this basically doing, this does is, let's just put it back a little bit. Oh my. Okay, wow, this is a train wreck. This length of wire, maybe I can solve some of that in editing. What do you think? This length of wire, so we're electrically changing the length of wire, which a lot of times is important for trimming your antenna, particularly if you're doing a mobile antenna, right? It's probably high Q, and as in there's only a very narrow resonance point. Anyway, so those wires are connected at different points in here so that you can step it. And I have another antenna. Maybe I will show you where you can do that manually. Anyway, and then, so there's no real active components. You don't even, I mean, it's powered by the RF, if you will. There is a lamp, which is why there's a 12-volt socket in here. But then one of the things that I find wonderful here, so let's see, you can bypass. Okay, whoop, yep, always found this nice. So is it gonna get back in focus? I'm gonna have to learn how to do manual focus on this thing. So what ends up happening is you have forward and reflected. There's two little needles, and where they meet is your ratio, and you don't want it to be above 2, basically, of reflected power. I'm not going to go into reflected power right now. To be able to change capacitance, this is a super neat mechanical capacitor, right? It's a variable capacitor, and all we're doing here is we are running the RF through, right? Or you could run a voltage through, and these plates, I don't know if we can see this well enough, I'll do another picture, but you see that there are these plates, and they're very close together. Okay, and by them being very close together, and then you changing what the overlap is here, you're able to change the capacitance. And one is for the at the antenna side, one is at the transmitter side. So see, what you do is you plug in your antenna and you plug in your transmitter, so like your radio, right? And then those go to each of those. Those go to each one of those. Okay, I've already definitely taken too long. The technique used to tune a manual antenna tuner, especially as you're tuning up and down the bands, is it's a skill. Now this is not. You know what I didn't do? I did not mark where 0 is. Okay, so it looks like 0 is all the way closed. Well, to where there is no overlap between the two. There we go. that is nice. Those knobs definitely feel a lot better. And we're back. And this is this segment. And this segment is an idea that was given to me where, I respond to comments basically. And so let's just get right into it and do this nice little experiment. So Easy Hack, who comments on almost every video, and so thank you, I love you, and I check out his videos. Yes. So I guess Easy Hack is also a ham, and WSJTX is part of a whisper mode. I'm hoping that I didn't come in with the right browser here, but we're just gonna keep going. All right, so it's a wonderful open source software for weak signal. I do believe that, I think Easy Hack is over there in Canada, which is north of me. But anyway, so yes, definitely. I would love to make contact, whether it be with Whisper, a JTS call is the latest mode, I guess, that the kids are doing, if you will. So I definitely want to get back into some of those weak signal things. I need to get some of my antennas back up and running, and we'll be doing that. So let's see what he just responded 20 minutes ago. Yes, definitely. NVIS. So let's just talk about that for a second. Let me read the whole comment. Sorry. Not quite licensed yet, but he's got a wonderful QRP radio that he is using to decode. So see, now you can own a ham radio without a license, and we would say amateur radio license, right? So from the FCC, in case you're not in the United States, it's controlled by the FCC, who coordinates frequencies. And I'm just not going to go into trying to keep this tight. Anyway, but you can receive, just like you can receive any signal. You can receive and decode any signal that is out there. Now, what you do with that data and its decode, on the other hand, is, let's say, a question for the lawyers. Okay, let's keep moving along. But for amateur radio, which is a really great place to experiment and hack, we send out these packets that are particularly designed for weak signals. So it takes sometimes like 30 seconds to a minute for one of these packets to be transmitted, because it's using a lot of redundancy and a lot of other kinds of weak signal propagation characteristics. Okay, so I'm going to try not go into it at the moment. But it's some brilliant engineering by WSJT, or well, that's what's his call sign? WSJ. Oh, I forgot. I'm a bad amateur radio operator. Anyway, okay, so I do highly recommend that you get your technician's license or whatever is based in Canada, and then graduate. So there's just a lot that you can do on radio experimentation and not have to worry about the law or anybody coming after you, because that's frequency, that's spectrum set aside for not only experimentation, but for us to be able to assist in an emergency. And we'll talk more about those kind of things later on. This is where he was talking about his USDX. Let's just look that up really quick. It's a cool little radio. That was not a good way to look it up. Let's just go transceiver. This is the one they're talking about. My internet connection's a little bit slow. Here we go. So there's this rash of, or this wave, I'm going to say wave, of inexpensive, so that's a pretty good price, about $100. They can go cheaper, but but it depends on what capabilities you're getting. Anyway, these software-defined radios that are QRP or low power, that have a that are, I'm sorry, wow, I did not prepare for this at all. There's a 3D printed case. All right, these are software-defined radios that have hit the market based on, there's a few chipsets that have come out, and software-defined radio is very popular now because we have the commercial industry has embraced it, and so there are semiconductor companies that are producing chips that are by default software-defined radios. So and as a result, you can get into the hobby pretty inexpensively and get a lot out of it. So these being about $100 QRP, these will transmit. And the thing that most people don't realize is that particularly for HF, so this is this 7.03 megahertz there, and it's in CW mode. I don't know if you can see that, but it looks like it's a CW mode there, meaning continuous wave or Morse code. This in a long wire at very low wattage, what you're doing is you're bouncing your signal off the ionosphere, and I could talk about this for a long time. What happens is those radio signals below a certain threshold, or what we call high frequency, they don't penetrate the atmosphere, and instead they go up, and based on the curvature of the Earth, they go up and they bounce back down. And you really don't need a lot of power in order to accomplish that. NVIS, let me go back to this really quick. So what I had told him, I had mentioned NVIS antenna, and what that is a near vertical instance and NVIS antenna. So I've used these several times. Yes, near vertical instance skywave. Okay, so the trick is that this is what I was talking about. These radio signals, they go up and they bounce back down. Okay, well, in traditional kind of ham radio, vertical antenna is up, and the radiation takeoff, okay, is such that you're creating a donut, okay, of coverage, and we call like a dead zone. And so if you're trying to use HF to communicate locally, then what you need to do is change the takeoff angle of your antenna such that it goes straight up, basically just straight up and then back down, because the curvature of the Earth and everything else will just kind of, within about a 500-mile radius. Yes, that's what we consider to be local in HF, under 500 miles. But I mean, it's like if you're trying to get something 30 miles, or in my case, I have this challenge where I'm trying to do something 16 miles, but that's not quite line of sight, right? You can use NVIS to communicate within that like 500-mile range, and have reliable local communication. And it has to do with the antenna design. What it's also nice for is if you are trying to eliminate the noise from other stations. So you only want to hear generally local traffic. Again, that is that can be accomplished with this kind of antenna, so that the signals that you're receiving are coming from a particular refracted angle, right? Okay, so it's not super precise because again, you have a curvature, you have these radio waves, and they're scattering all about. But anyway, what is precise is that dead zone. You need to shoot straight up, otherwise all you're doing here, if I take this off, no, I'm just using my hands. I should use a graphic instead, obviously. Oh no, if I'm smart, I'll just transition here. So this is what I was doing. It's a V. I should just insert a diagram, but I can't be bothered at the moment because I'm going to have to get to work soon. But so instead of you're taking off your angle, let's imagine the top of my head here. Oh, now I'm making a nice little heart. The top of my head. How do I do this? I'm horrible. Here's the point. Okay, so we got a plane. You're going to bear with me all the way through this. Well, I mean, you can always turn off. This doesn't show up well, so I'm going to use this white marker. All right, so the point is that you can imagine it happens in 360 degrees, okay? But if you've got kind of a normal, what you consider a long-range antenna, you would have for HF, where you're trying to bounce your signals off the ionosphere, you have this takeoff angle such that maybe even you have it very low, right? And I'm sorry to all the flat earthers, but the reason why these things work is because of the curvature of the Earth. If I have a lower takeoff angle, then that means that when that signal bounces back off the atmosphere, it's going to come down further away than if I had a higher takeoff angle, and then it came back down to me locally, and that's NVIS. Okay, didn't even think I'd get through that far. All right, let's go back, see if there's not very many comments. So yes, I already applied to this one. Some of these. Oh yeah, so I did get this RFID reader. I did not hook it up to my computer yet, and it's apparently got some software on it that I can use to crack the encrypted, what is it, 30 megahertz, 30 hertz, I don't remember. Anyway, I'm still learning some of the RFID stuff. All right, so those are only two main comments. And then I think the other thing, the other, I'm just going to cover, oh no, I clicked, now I've messed up my camera. I had it perfect, and every time I do that, this camera is, well, it's problematic, folks. As I came back, so this is our Discord community, and you should definitely go check it out. I'll try and post the link below. But I apparently, from just kind of my little announcement yesterday, I spurred some interesting, some interest. So more people are interested in satellite work than I thought. Captain Ron didn't, I got to talk to him a little bit about the fact that I can do, so amateur television has, in the United States, has allocation within channels that are pre-programmed, frequencies that are pre-programmed in to your television. And so that's one of those things that we can do. There's satellite work. Yeah, I feel like I've already probably taken enough time here, but let's show Captain Ron's, he's building this tracker. Look at that. So you'd normally have like a little dome on here, right? And put this on your RV. And good job. Oh my. This is fantastic. I love this stuff. This is the kind of things our community is into. And I suspect that you are too. So you should check it out if you'd like to support. I do have Patreon. I'll mention again more specifically, but I am dropping the sponsorship from PCBWay, not because they haven't been awesome, because they have. They have been. Thank you, Zoe. Very awesome. I just let's just say I did my research. I did some research, and they came in. PCBWay came in pretty early, and they were wonderful. And I thought, hey, this is a cool thing to try out. Doing a sponsorship's pretty. That makes me a real YouTuber, right? But honestly, doing invoicing for them and coming up with the ad copy and stuff like that, kind of, I think, was just taking more cycles than I was willing to. It was blocking me from putting up things, and so maybe we'll do something else in the future when it makes sense. But going to drop sponsorship for now. If anybody else comes along, I'll probably entertain the idea and talk to y'all about it. But in the meantime, what I think I'm going to do is try and raise support via Patreon, just to help fund the gadgets and the gear and things like that. And we'll see where it goes. All right. This has been your dose, your daily dose, your vlog. It's already gone way over, but there you go. We're going to see if I can get it edited and out before the end of the day. Happy hacking.